Welcome back, guys. So in this recording, we're gonna solve the same example that we solved last time using 8 by 1 max, but now with 4 by 1 max. Again, it's a function implementation. We wanna implement some function that has some main terms, okay? And it's basically a function of ABCD for variables, but now it's 4 by 1 max. This is the only change. Since we have 4 by 1 max, now we have the two selection bits. So going into same steps, assign some of the input to these selection bits. Let's assign, for example, A and B. So A is 1, B is 0. Okay. So basically, we're gonna get the first input, second input, third input, fourth input, or number 3, as a function of C and D. Okay. Since A and B is 2 bits, we have 4 combinations. So we're gonna divide the big truth table into 4 smaller truth tables like this. Okay. In which each one has a special case or one combination of A and B. Here is 0, 0, here is 0, 1, here is 1, 0, and finally we have here 1, 1. Okay. When AB is 0, 0, 0, 0, basically F will be connected to D. I'm sorry, I0. Just forget about what's in here, you know. We're gonna figure this out right now. So in that case, F is equal to I naught. Okay. So we have to find a function for F based on the values of C and D and so we have here 2 variables, C and D, C and D. So just, you know, assign, so 0, 1, 0, 1, one group. So if, or I naught in that case, equal to D. That's why here we connect the input 0 to D. Then 0, 1, second truth table. And in that case, F is equal to I1. I mean, we're gonna connect F to I1 like this. If A and B is 0, 1, basically. So if we look here, it's not a pair. No, let's do it with, you know, Carnot map. C and D. So 1, 0, 0, 0. It's one group. So F is equal to C bar D bar. Or you can write it as C plus D or C or D totally bar, which is C nor D. C nor D, nor gate. Okay. So you can do whatever you like. I like to do it using the NOR gate. But of course, if you do something like this, it's also acceptable. So we're gonna connect to I1 because this is, in this case, F is equal to I1. We're gonna connect to I1 here to C nor D. Then the third case, in which AB is 1, 0. I mean 1 here, 0 here. So in that case, the multiplexer will choose the second input and connect it to the output. Here it is. This is really easy to deduce because basically, look, 0 and 0, 0, 0 and 1, 1, 0, 1 and 0, 0, 1 and 1 is 1. It's an AND gate. It's just a truth table of AND gate. So F is equal to C and D, which is basically what I have here in I2. Finally, and the most easy one is that case here when A and B are 1, 1, and look, F is equal to 1 all the time. You don't need, you know, any Carnot map or something. So we're gonna connect I3 here to 1. Okay, that's basically, you know, the guys the design. So let's check, let's verify. So we're gonna remove the mess as usual and see. Let's do with green. A, B, C, D. Let's put 0, 1, 1, 1. 0, 1, 1. Okay. So 0 here, 1 here. That means let's write it in that way. S1 is 0. Here is we have 1. Yeah, this is case 1 or number 1 or input 1, which is that one here. Okay, so we have here C nor D. One nor 1 is basically 0 because 1 or 1 is 1. Then we invert it, it will give us 0. So basically F should be 0. Let's check on the truth table. 0, 1, 1, 1. 3 ones, 0. Yeah, this one here. Yes, F is equal to 0. You are right. Let's check another case. Let's choose another color, black for example. Let's take for example 1, 0, 0, 1. So now S1 is 1, S0 is 0. So we should take the input number 2, which is that one here, which you have C and D. So it will be 0. So F is 0. Let's check on the truth table. 1, 2 zeros, then 1. Yes, this guy. Yes, we have 0. We are correct. And of course, you're going to check all other cases as well. Okay, guys, that was basically, the second implementation or the second design for, this function in here, but this time using a 4x1 max. Thank you very much, you guys, for watching this video, and see you in the next video. Bye-bye.